all right? This is going to form basically a C shape. So let's just say in the next generation, we end up with 3 white rabbits, all right? And we kill those, and we end up with see, that would be 47 brown rabbits, and that would give us 12 that we had to get rid of. So let's see, 47 minus 12. All right, so we need a total of 70. I'm just trying to make up some realistic numbers here. Okay, and so let's say that we had 60 of them as brown beans and 10 of them as white beans. Okay, that would give us an allelic frequency of 0.85, because here we're going to take 60 plus 10 equals 70. 60 divided by 70 gives us 0.85. Oops, I put that in the wrong column. Here should be your 0.85, and nothing there. Okay, just 85. And here we're going to have 1.5 and 0.15. Okay? Next generation, we only end up with 1 white rabbit, which means we got to kill 13 of them. Let's say we had 59 brown beans then, and then we ended up with 13 of them being white beans. And so what we end up with here is 0.82. Whoa, should that happen? Again, I put that in the wrong column. Here should be your decimal point, 0.82, and that's 82. And this should be 18 and 0.18. Okay, should have that happened? Well, actually it can. What's happened now is now we've reached genetic equilibrium. So if we look at our chart, again, we basically have something that happens where it goes down to 0.85, and then it comes back up just a smidge, and same thing here. And so you're gonna find is if you kept extrapolating this out over several generations, you would end up with a curve that's kind of just gonna hover right around between 80 and 85%. And the white gene is never going to disappear. Over several years of running this lab, I have only lost the white allele like 2 or 3 times. Now remember, this is over several years, and every year I have 30, 40 different groups of students to do this. So to say I've only had 3 or 4 groups ever completely lose the white allele, that is pretty exceptional. Like, you don't lose the allele. Why is it important that you don't lose that allele? Well, that maintains your genetic diversity. You never know when in the future maybe there's some reason that the rabbits need to have that white allele. Like, it maintains their genetic diversity. And so because of that, that white allele can come back, give them that variation and that possibility to have an adaptation where they become white rabbits that is now more advantageous in a particular environment. Okay, so you don't ever want to lose the allele. Can it happen? Yes, and that's when you have small populations, and that's why bringing populations down is critically dangerous. When you get really really low populations, you lose a lot of alleles because remember, Hardy-Weinberg doesn't impact, it doesn't hold true for small populations. So although Hardy-Weinberg was kaput for the early part of this because of natural selection, once natural selection takes place, we kind of reach a genetic equilibrium. And over the next several generations, it's just going to hang out really close to between 80 and 85%. And so the allele never completely disappears if you keep the population large enough. Like I said, I've had a few groups lose it in that it can happen by random chance, but also it can happen as a result of having a small population. And that's why ecologists are doing things like stockpiling DNA of critically endangered organisms. If you think about it, if a rhinoceros population gets down to a few hundred, it's never going to rebound and gain that genetic diversity that it once had. And so is it going to be able to adapt and be a healthy population? Most certainly not. Anyways, I hope that you were able to actually complete the lab on your own. If not, I'm hoping that you were able to understand this. And if you have any questions, again, feel free to shoot me a message and ask. Have a nice day.